So rationalizing denominators is where we adjust things so that there isn't a radical in our denominator. Typically that's because it's easier to divide by whole numbers rather than square roots of numbers. Also, it creates kind of a standard way to end simplifying things. So something I'll refer back to actually is at the end of our last video. Something else we could have done with that last example is, what if I had simplified that fraction underneath the radical first, that 6 over 100? Because that would be the square root of 3 over 50. And if I simplify that down, so square root of 3 over square root of 50, and then what I could do is that 50 could be split up into a 25 times 2, and then we'd see the square root of 3 equals, the square root of 3 over 5 times the square root of 2. Notice that that looks completely different from that square root of 6 over 10. However, they're actually the same. If you plug those two numbers into a calculator, they'll give you the same number out. What's just different is their appearance. With this version I just did here, we have a radical in the denominator. So what we'll do is we'll go through, I'll show you how to rationalize denominators, and we'll see how to get here. And in terms of simplified forms, the rationalized denominator is preferred. So having a denominator without any radicals. So let's talk about how we can do this. So we're simplifying here. We don't have equations. So with that, we have to be careful about what we do. And it's kind of like with fractions. Like if I wanted to add a half plus a third, and we needed to create a common denominator, then what we would have to do is multiply by a version of 1, a unit fraction. In this case, a 3 over 3 and a 2 over 2. And the idea behind that is by multiplying by 1, we're not actually changing anything. We're just changing kind of the appearance of it, but in terms of value, it's the same thing. If I simplify that, 3/6 is the same thing as 1/2, it's just in a less simplified way. And then plus 2 over 6, which is the same thing as 1/3, it's just less simplified, but we get it into a form that we can actually work with. Same idea here. What we're going to do is multiply by a unit fraction, so a fraction that's equal to 1, so that we're not actually changing anything, we're just changing how it appears. So if we have a single square root in the denominator, then what we're going to multiply is that denominator. So the key to this is we're just focused on the denominator. Really anything could be going on in the numerator there, and it wouldn't matter. All I need to see is that there's a square root of 3 in the denominator, so that's going to determine my unit fraction. So what I'm going to do is multiply with this unit fraction of square root of 3 over square root of 3. Now when we do this, in the numerator I get 2 times square root of 3. In the denominator I get the square root of 3 times square root of 3, which would be the same thing as the square root of 3 times 3, which is 9. And then if I simplify that, in the numerator, that's still 2 times the square root of 3. Square root of 9 is equal to 3. And then that would be completely simplified, and we have rationalized the denominator, and there's nothing else to do there. So what we did is we took something in this form of 2 over square root of 3, and we've adjusted it to another form, so those two numbers are exactly the same. It's just this second form doesn't have any radicals in the denominator. Now, in terms of simplifying here, there isn't anything to simplify. And what I like to do is I like to think of this square root symbol as like a trap. You can't get in there unless you also have that square root symbol. So there can be an instinct with students to cancel out those 3's, but you can't do that. One of them is trapped under a square root, and one of them is outside of a square root. So with that, if there was anything to cancel between the 2 divided by 3, we could do that. But without anything else with the radical, we can't do anything with that square root of 3. So just be careful to not cancel places that you shouldn't when we have these fractions. So let's visit back to this example here, because what I would do is I would multiply by a unit fraction, and what I would use is the fact that I need to get rid of that square root of 2 in the denominator, so I would use square root of 2 over square root of 2. And what that would do is in the numerator, I would have the square root of 3 times square root of 2, which is the square root of 6, and then 5 times square root of 2 times square root of 2, which would be the square root of 4, which simplifies to 2. And as we do this more often, what you'll get used to is when you multiply the square root of the same number with itself, you just end up with that number that's underneath the square root, because you're basically squaring those numbers, so you really just end up with that number. And if we simplify that, that would be square root of 6 over 10. And if we do a comparison, that's how we would see that original number coming out that we got the first time. So when simplifying, we're going to rationalize the denominator so we get this kind of standard answer coming out rather than an unsimplified answer that we would have had in that other form. Alright, let's get some practice with these. So 5 times the square root of 6. So I'm going to multiply this by a unit fraction, and we're going to have square root of 6, square root of 6. Again, it's all about what's in the denominator. So in the numerator, that'll be 5 times the square root of 6 over, and then I'm going to keep doing this step. If you get used to this and just skip to having 6 in the denominator there, that's perfect. But just to show you why that's happening, it's that we're taking 6 times 6, so that turns into a square root of 36, which simplifies to 6. And then we can't cancel anything out. I would look across that 5 and 6, but we can't do anything with that, so that stays put. Here, what we'll have is multiplying by our unit fraction using the square root of 5, both the numerator and denominator. So in the numerator, 20 times square root of 5 over square root of 5 times square root of 5, which is the square root of 25, which would be 20 over square root of 5, and then square root of 25 is 5. And now in this case, I have 20 divided by 5, so I can simplify those to a 4, and then we still have that square root of 5 multiplying on there. Alright, another round of examples here. Times a fraction with square root of 12, square root of 12. So this will be 1 times the square root of 12 is just the square root of 12 over the square root of 12 times 12, which is 144. So this will be square root of 12 over 12. And again, that's stuck just like that. We can't simplify anything because we have that 12 is stuck underneath the radical where the other one isn't. Okay, with this square root of 25 over square root of 2, what we're going to do is break up our radicals. So we'll have the square root of the numerator over square root of the denominator. And what we can go ahead and do is simplify that numerator. So square root of 25 is 5 over square root of 2. And now let's go ahead and multiply by our unit fraction to get rid of that radical in the denominator using square root of 2 over square root of 2. So 5 times the square root of 2 over square root of 2 times square root of 2, which would just be 2. So that's rationalizing our denominators when there's a single term in the denominator, meaning there's just a single radical. Or even what we looked at with that last example from the previous video is we could have a number outside of the radical. The key is that there isn't anything adding or subtracting on. But our next video, we'll look at what if there is something adding or subtracting on.